to 7.2.02. That's the start date. Welcome to the enterprise. So we talked about proportional relationship. It's a proportional relationship. It's literally just are these two ratios, and I'm making this up. Let me pick two ratios here. Oh, there you go. 3/5 and 6/10. Are they equal to each other? Well, one way we can do this is to cross multiply. Cross multiplying is just a shortcut of setting those two denominators to have the same denominator, right? And then comparing them. So in this case, if we cross multiply, 3 times 10 is 30, 5 times 6 is 30, and they're equal to each other. So what does that tell you? It tells you that 3/5 and 6/10 are proportional. Now, another way to see if these ratios are the same is to simplify. Take 3/5, simplify to its lowest terms, which is already simplified. Take 6/10, simplify it. Well, to simplify 6/10, I'm going to divide top and bottom by 2. So if I take 6 and divide it by 2, I get 3. If I divide 10 and divide it by 2, I get 5. Are these two ratios now the same? Yes, they are. Okay, so that's another thing you can do. Can you also think about this? What was the scale factor? What took me, right? So remember, what took the 3 to become 6 times 2, right? So I increased it by a scale factor of 2. So the bottom, was it also times 2? Yeah, look, 5 times 2 is 10. Right? So equivalent ratios, they might have the simplest, different numbers, but they are equal to each other. Let's get this started, because, oh no. Let's move this. Okay, here we go. So first, oh, they said complete the table. So you had a choice. So going, oh, I'm glad we're doing this. So we have quite a few examples. Choices. Now they come as X and Y. Very sneaky. X and Y relationship. So we can work, I'm going to do this one where I'm going to try to find this number. Now put a dot there, showing multiplication, right? And I'm going to go this way. 30 times something is 3. So I'm going to try to find that number. Right? And one way I can do it, well, what if I actually, let me go this way. Let me find this, because it's easier if I look this way. 3 times what is 30? It's times 10, right? So if going this way, right, 3 times 10 is 30. Well, going the other way, it would be what? Divided by 10. Agreed? So 30 divided by 10 is 3. So in this case, 120 divided by 10 is 12, right? Because I'm going to the right. So, and then this one, 10, going this way is times 10. So 10 times 10 is 100. So I want you, let me see if I can clean this up a little bit. Let's see if this works. Going this way, times 10. I'm missing a number. Wasn't this, sorry guys, let me just redo this again. It was 12, sorry. This number was 12. So going this way, times 10, going that way, times 10, going that way, times 10, right? And then if you actually want to check and go the other way, 30 divided by 10 is 3, 120 divided by 10 is 12, and 100 divided by 10 is 100. Okay, so I'm going to leave that there. Now, on this side, number 2, I promised this one. No, I didn't promise, but I'm going to do this way. 1 times what is 3? It's times 3, so I'm going to write times 3. So going this way, it would be times 3. What's 1.5 times 3? It would be 4.5. Now I have to go from here to here. 1.5 times what is 12? That would be 8. So 1.5 times 8 is 12. So here to here, we're going to multiply by the same scale factor, and 1 times 8 is 8. You can do a check if you wanted to, right? Make sure that everything works, and we're gonna go this way. How does 1 become 1.5 times 1.5? 1 times 1.5 is 1.5. That worked. What about 1 times, sorry, 3 times 1.5? Is that 4.5? Yes, it works. And then 8 times 1.5. Is that 12? Yes, it is. So I did it both ways. I didn't mean to, but I did it both ways. This one, let's go this way. Can you figure out 15 times something is 45? 15 times 3 is 45. So once I have that number, look, it's so easy. 15 times 3 is 45. 1 times 3 is 3. And then this one, something times 3 is 0. Well, obviously, that has to be 0. If you decided, no, I don't want to do it this way, well, I want to do it that way. Think about it. How does 15 become 1? It's divided by 15. 15 divided by 15 is 1. Well, does that work on the other side? 45 divided by 15, is that 3? Yes, it is. Check. Check. This one. It's a decimal. Ooh. Let's go this way, I guess. Can you figure out 0.2 times this mystery number is 1? Think about money. You have 20 cents. What can I multiply 20 cents by to get $1? Right? What can I multiply 20 cents? Think about that. So it's 0.2 times 5. I hope you got that. Times 5 equals 1. So now that I know that, it's going to be times 5. It's going to be times 5. 1 times 5 is 5. And then what times 5 gives me 20? It's 4. So I like when we have this middle number here, which we're going to talk about soon as a unit rate. But right now, let's just go. Let's just know that if you're going in this direction, side to side, that has to be the same number. Well, let's go the other way. Just to double check. 1 times 5 is 5. On the other side, 0.2 times 5 is 1, so that worked. 1 times 20 is 20, so what if I have 20 cents and then multiply that by 20? Will I get 4? Well, use a calculator and see if that's correct. But you have options, right? You have options. Eric, entrance to a state park costs $6 plus $2 per person. The table shows the entry cost for several recent groups of visitors. It's a relationship between the number of people and the total and a proportional relationship. I don't like how they're sneaking here. Well, let's try it out. Well, 2 times, can you guys figure out this number here? What's the number that I can multiply 2 times to get 10? It'd be 5. If that's, right, if it's 5, we know that's true. We know that's 5. So that means that all of these should be times 5. Times 5. And right, this one's okay, this one is not okay, this one's not okay, and this one's not okay. So is this a proportional relationship? No, it's not. Let's do it a different way. All right, so let's erase that. Let's say you didn't 5 was times 5. Let's go, let me pick an easy one. Let's go 2 to 4. 2 times what number is 4? It would be times 2. So therefore here, it should be the same scale factor. It should have been 10 times 2, which should have given me 20, but it's not. Okay? So that also tells you it's not a proportional relationship. Let's try setup as a proportion. So when I have 2 people, the cost is $10. That's what that's saying, the first line. Let me set up a proportion. So when I have, let me use, well, I can use 3. When I have 3 people, the cost is $12. Is this a proportional relationship? Well, we can cross multiply, so let's cross multiply. So if I cross multiply, I get 2 times 12, which is 24. If I cross multiply these two, I get 3 times 10, which is 30, and they're not equal to each other. They're not equal to each other, which means not proportional. Let me simplify this. So that's one way. What if I wanted to simplify? 2 over 10. So let's take 2 over 10 and simplify. If I divide top by 2 and the bottom by 2, 2 over 10 is 1 over 5. It becomes 1 over 5. So 2 over 10 is 1 over 5. 3 over 12. I'm going to divide top and bottom by 3. 3 divided by 3 is 1. 12 divided by 3 is 4. So 1 over 4. Are these two ratios the same? No, they're not. Okay. The problem here is the parking. Okay. So if it was without the parking, so think about this. Entrance to a state park costs $6 per vehicle. So let me take the not the parking, the vehicle. Let me take the vehicle part out, and it was just $2 per person. And the car was free. So think about this: one person, $2. Two people come into the park, it'd be $4. Three people come in the park, it'd be $6. That would have been a proportional relationship. Yeah. Now, because of the vehicle, it changes things around. So one person comes into the park, pays $2, but he has a car, so we're gonna add $6. So he's paying $8. Two people come into the park, they're gonna pay $4 for the entry fee plus $6 for the car they're in. 4 plus 6 is 10. Now, does it look like that it's proportional? No, it's not. So this, and then let me do one more. 3 people drive into the park. They're gonna pay $6 for the tickets, plus $6 for the car. So that becomes 12. Right? So is this a proportional relationship? We can tell it's not. And what makes it not proportional? Because we have to account for the vehicle. There's a little extra there. And eventually we're going to show this on the table, on the graph, and you're going to see what a proportional relationship and a non-proportional relationship looks like in the graph. They differ a little bit. The y-intercept. Star charges $4.80 for 16 ounces of bubble tea. Okay, so you go to the store, you say, I'd like the 16 ounce. You pay $4.80. You get a 20 ounce, you pay a certain amount. You get the whatever ounce, and you pay $7.20. Complete the table so that it shows a proportional relationship between the ounces. So if this was proportional, okay, what would be the cost? Well, can you guys figure out this number? 16 times what is 480? Because if you find that number, I can just go and use it, the same number 3 times, right? This is the unit rate. So 16 times what is 480? Well, you can figure that out. What can we do? We can do 480 and divide that by 16, right? So if you do 480 and you divide that by 16, divide that by 16, you get 0.3. 16 times 30 cents is 480. 20 times 30 cents, can you figure that out? Is $6. Right? Right. 0.3. And what's the size here? And what's something times 0.3720? You can just divide. You can take 720 and divide by 0.3, and you're gonna get 24. The 24 ounce is times 30 cents, because it's 30 cents per ounce, right? The unit rate. We'll get to this eventually. So I don't know. Let's say if I had the 50 ounce tea, well, times 0.3. What if I had the 100 ounce tea times 0.3? Right? It's always times the price per ounce, right? Because we know. So, and what's good about this is even though we don't have it, we can go backwards. 16 ounce costs that much. 10 ounce. We can even go to 1 ounce. 1 ounce would be a ridiculous tiny amount. So if you had 1 ounce of tea and you multiply it by 30 cents, how much would it cost for you? 30 cents. Right, so this number here in the middle reflects the unit. It's the price you pay per ounce. Every ounce of bubble tea is 30 cents. That's what it's. So once you have the unit rate, you can just use it over and over and over again. But whatever number I give you, what about the 200 ounce of bubble tea? ridiculous size, but you do times 0.3. Right? You always multiply by the unit. All right, so that's one way. But what if you didn't like it? I don't want to do that. Well, then you can find relationships. Okay, let's go this way. 480 times something is 720. Ugh, do you really want to do that? Let's see. Well, let's do this one first. 16. 16 times this number that I don't know equals 20. Right? We're looking for the scale factor. So imagine a rectangle. Right? I'm going to imagine a rectangle. And this measures 16. And all of a sudden, we use a scale factor. And that rectangle, this side, went from 16 to 20. Remember when we did scale factor? This is an increase, right? From 16 to 20, it's an enlargement. It got bigger. So what do? We do big over small. So take your number 20 divided by 16, and you should have gotten 125. So this, from 16 to 20, 1.25, which means going from here, from 480 to that empty spot, you multiply it by 1.25. So 4.8 times 1.25 is $6. Okay, so that's that one. What about, no, change colors? What about 4.80? Let me erase this. How about the 4.80 going to 720? And figure out what was it multiplied by, because I need that to figure out 16. What did I multiply by? Right. So again, think about this rectangle. This measures 4 meters and 80 centimeters. 4.8. 4 meters and 80 centimeters. And this one, it now measures 7 meters and 20 centimeters. Again, it's an enlargement, right? It got bigger, so the scale factor. So to find out how it got bigger, there was a scale factor. Well, it's big over small, so 720 divided by 480. 720 divided by 480 equals 1.5. So 480 times 1.5 is 720. So on this side, 16 times 1.5 is going to give us the number that we're missing, and is 25, which was exactly what we had before. Okay, so either you do it this way, or you find the unit rate, which was 0.3. And multiply that by 0.3, multiply this by 0.3, multiply this by 0.3. Your choice. Okay, and that is that. No, there's more. No, there's more. No, yes, there is. Okay. All right, not a big deal. Let's finish this. Complete the table so it shows a proportional relationship. Okay. Pick a one. You want to do this, right? But if you do this, you need to find 3 different numbers, right? 3 different scale factors. If you go this way, you're going to multiply 1. That's the same number over and over because you found the unit. So which one you want to do, it is really up to you. I like to do it this way because it's just one number. Well, how do I find the number? So that says 8 times some number gave me 10. How do I find that number? Well, again, think about it in terms of scale factor, right? So it's an enlargement. How did the 8 become a 10? So it got bigger. So scale factor is big over small, and you can do 10 over 8, and 10 divided by 8 is 1.25. So that's our magic number. So it's times 1.25. I can go ahead and write times 1.25, times 1.25, and then times 1.25. And you can find our number. So 20 times 1.25 is 25. 13 times 1.25 is 16.25. This one, something times 1.25 is 12.5. So obviously it's 10. Sorry. So this one's 10. Okay, so I found this number. What if I didn't? What if you don't want to do that? Well, then you're going to go like this. And I don't know if you want to do that. I really don't know if you want to do that. But let's do it because that's what we do. So 8 became a 20. So again, think in terms of scale factor. This was 8. It is now a 20. It got bigger, right? So we're going to go scale factor 20 over 8. Which is 2.5. But this was 2.5, which means on this side it's going to be times 2.5. And 10 times 2.5 is 25. Ugh. 8, oh, change colors. So you can see that sometimes this method is probably 8 to 13 and then 10, right? So I need to find out 8 times something gave me 13, so I can multiply that and use it the same on the other side. Okay, so if you take your calculator and again divide 13 divided by 8, you actually get the number 1.625. Yuck. So this was multiplied by 1.625. So if you take the calculator and multiply that times 8 just to confirm, you get 13. So which means that this side I'm going to multiply that by 1.625. 10 times 1.625 is 16.25. Last one, just for fun, I need to now find out, for fun, he said, for fun, 8 times something, right, to give me this, our mystery number in here. But in order to do that, I'm going to figure out what do I multiply 10 by to get 12.5. Well, if you divide 12.5 divided by 10, you're going to get that number. So just to be different, here's what I'm going to do with this one. So I have 8 honey for 10 cups of flour. Right, so I'm going to use a proportion. Right, maybe this helps you. So 8 tablespoons of honey for 10 cups of flour, and then I know that X cups of honey. So actually, let me leave it as blank. So honey on top, and then flour at the bottom, and then I'm going to use these two. So where do I put 12.5? Because this is what I need, right? 12.5 cups of flour. So it says that if I use 8 cups of honey, 8 tablespoons of honey, I need 10 cups of flour. How much honey do I need? And that's what we're trying to figure out. How much honey do I need when I use 12.5 cups of flour? So again, you don't have to do this, right? But I'm going to do it. Set up a portion. 10x, if you cross multiply. And then 8 times 12.5, and you get 100. Divide by 10, divide by 10. X equals obviously 10. So this mystery number that we needed was 10. But we already knew that, right? So that's it. Wait. I don't think I'm done. Oh. Spiral review, yay. Solve each equation. Okay, so let's solve this like you did it in the 5th grade, 4th grade. Half plus x equals 2. We want that equation to look like this. How do I isolate x, right? What half times something equals 2? Well, to solve it like you've been solving, well, we divide the equation in 2 sides, the left and the right. Right? I want to isolate. I want to have x by itself. So in order to have x by itself, I'm going to get rid of the half. I'm going to do minus a half. And if I do minus a half on this side, I'm going to do minus a half on the other side. Half minus a half is 0, goes away. I'm left with x. And then 2 minus a half is 1.5. So there's my answer. I'm not going to check. 2/3. 2/3 of a y equals 6. So if I take 2/3 and multiply by this number that I don't know, it equals to 6. So how do I get that equation to look like this? So y is by itself. How do I get rid of the 2/3? Well, if you think about what's happening between 2/3 and y, it's being multiplied, right? So that's no different than this. What happens if it was 5y? Let's think about this equation. 5y equals 10. You would say, oh, that's easy. Divide that by 5, divide by 5. The 5 simplifies to 1, and y equals 2. No, it's the same idea here. We're going to divide both sides by 2/3. I'm going to divide this by 2/3. I'm going to divide this by 2/3. Thing is, division, if you think about dividing fractions, what's 2/3 divided by 2/3 is the same thing as 2/3 times the reciprocal of 2/3, which is 3/2. So 2/3 divided by 2/3, think of it multiplied by the reciprocal. Guess what happens? Everything simplifies to 1. So this actually ends up simplifying to 1, which is what we wanted. On the other side, 6 divided by 2/3 is the same thing as 6 times 3/2, the reciprocal. Let's put that over 1. 6 times 3 is 18. 1 times 2 is 2. And our answer is 9. You can check. I don't want to. Same thing here. 3 equals 1/4 of b. So let's do the shortcut. So in order to get rid of that 1/4 and have my answer look like this, where b is isolated, I need to get rid of 4. So to get rid of 1/4, I'm going to multiply that by the reciprocal of 1/4, which is 4/1. If I multiply that side by 4/1, I'm going to multiply the left side by 4/1. This all simplifies to 1, and that's how I get b by itself, because 1 times b is b, and what's 4/1 times 3? Just 12. So the answer to that is just 12. But you already know that. What in the world is this? A student makes a scale copy of a rectangle with the dimensions of the original rectangle. Let's try it out. So it's 3.5 by 3.5 and 2.5 meters. Select all the possible dimensions of the scaled copy. So let's actually put this as a fraction. 3.5 over 2.5. All right, let's bring the first one to the front. 1.75 meters to 1.25 meters. Well, what can we do here? Are these two the same? Now, are they? 3.5 divided by 2 is 1.75. 2.5 divided by 2 is 1.25. So 1 got scaled down by a half. Right, so A is okay. B, let me change that. And let's write 7 and 5. Well, you can cross multiply, be my guest, but I'm just quickly, this one is nice that you can quickly see that obviously 3.5 times 2 is 7 and 2.5 times 2 is 5, so B is equivalent. Let's try C. 7 and 6, obviously not. Think about how does 3.5 become 7 times 2 is 2.5 times 2 is 6, obviously not, so that's not it. 10 and 2.5. Oh, duh. 2.5 times 1 is 2.5, so the same applies on top. It's 3.5 times 1, 10. Obviously not, so that's neither. And the last one. See, proportions come in handy. 10.5 times 7.5. That looks okay. It's a times 3 relationship, so it's a scale factor of 3. 2.5 times 3 is 7.5, that's true. 3.5 times 3, 3.5 plus 3.5 plus 3.5 is 10.5. Yes, it is. So this one also works out. Now that's it. And I'm going to have